cannot respond as fast as the PLC can. So sometimes we deliberately put timers in there to basically delay an output to give what? To give the mechanics time to respond. So timers are used timers are used a heck of a lot more than counters. But you can understand what counters would be at. Counters is important to keep up with how many devices you ran in a certain day, how many devices you ran in a year, right? Or if you're packing boxes and each box requires 12, you might pack 12 and then shift over to another box, right? You understand? So counters are valuable. It's just that we couldn't do counters with control logic. So what we had to do in relays is we had to have an electronic counter that we would add to that feature. So timers. So timers, these are going to be by default. If you're on 1000, you have no option. But if you're on the 1100, you can create more timer files, data files if you want to. By default, it assigns it to T4. So timers are kept inside T4. So all our addresses will start off T4. And then timers are made up of 3 words per timer. So we're not going to, when we set up a timer, we're not going to set up a bit number. We're not going to set up a word number. We're just going to give the timer a number. So we can have timers in different ways, and this is what the book kind of covers. And if we have time, I'll show y'all in Ars Logic, in the TIA portal, you can set up timers in different ways. We're going to pick up a new instruction here called the move instruction, which is really, really powerful. And if I can get Logic Pro working, I'll really do that. Fixed timers, variable timers, single input timers, and double input timers. So some timer instructions have what we call an enable on your timer. Our timers doesn't do that. We use what we call single input timers. These are the actual contacts. If I was going to do it in relay logic, so if I was to come over here and to have a timer, the timer itself gets exactly the same symbol as a coil. It's just a circle with, somehow we're going to identify the timer, so I'm going to call it T. And then we would come down here and we're going to have several options available to us. So this would be the actual contacts. So we have 2 types of timers that we're going to deal with. We're going to deal with an on delay timer and an off delay timer. So an on delay timer means when something happens or when the relay coil gets energized, it's going to wait a certain time. So if this was an on delay timer, then let's say it's set for 10 seconds. That means I come up here and I close that button. Nothing happens. The light didn't come on until what? 10 seconds there. So on delay timers, they start timing when the coil is energized. And their symbols, if the arrow points towards the symbol, these are on delay timers. So here's a normally closed. So if I did this one, if I came over here and did the same thing, and I use this symbol right here. I'm sorry, point toward it. Let me erase that and make sure. So I'm going to draw it above the line. I'm going to come up here and put an up arrow. This is an on delay timer. So how would this work? I press the button. So without the button pressed, the light would be on. I press the button after 6 seconds. or 10 seconds, the light will turn off for this one right here. So the normally open on delay will close after the time. The normally open, the normally open would close after the specified time, and then the normally closed would open after the specified time. Then we have what we call the off delay. So off delay, my dome lights in my car, most of them do it now. But when you open the door, right, they come on. And then when you get out and close the door, they stay on for a little while until they go off. So that would be a perfect example of an off delay timer. So an off delay timer would start timing after the coil is de-energized. That makes sense. So my headlights on my car do the same thing if I don't turn them off manually. So if my headlights are on, I get out, they come on, and then after a while I close the door and it stays lit, and after a while they do what? They go off. So this is the example of off delay timer. These are the actual contact symbols for relay logic. We don't use those symbols in PLC. We've only got two symbols available to us. For the contacts, we got this and this, right? Everybody okay? So on delay timers and off delay timers. So on delay timers start timing after the rung is true. Off delay timers will start timing after the rung goes false. So now we've moved over to PLCs, right? So start timing when the coil is energized. Normally open contacts closed, and normally closed contacts open when the timer is finished timing. Contacts immediately revert to the normally state when the timer accumulator register reaches 0. And this is another problem we have, is this guy right here are calling these registers, and these are not registers, these are words. Registers are inside the microprocessor. These are not inside a timer. So here they're talking about contacts. Here they're talking about elements or words inside the timer instruction. Delay before contact switch when timer turns on. No delay in switching when the timer turns off. Are we okay? Yes or no? Off delay timer. Start timing when their timer coils are de-energized. Normally open contacts closed, and normally contacts open when the timer is finished timing. The contacts revert to their normal state when the timer accumulator register or word equals 0. So there's actually 3 words for every timer that we create. Coil format, that's available. Not with RS Logic 500, but coil means we would have the symbol for a timer. We'd pull down a timer coil, and then we might pull down a T on. What do you think a T on would be? Close. Oh, I'm going the wrong way. Good. No, we don't have a timer. There's no such thing as a timer on. It's a what? On delay timer. So I would pull down a coil that says T on. So that would be a T on. That would be an on delay timer. And a T off would be an off delay timer. Everybody okay? And then instead of putting an address, or we'd have to give it an address, we'd call it some timer, and we'd give it a number. And then down below it, we might put 2 seconds. And that would be what we call the coil format. which is nice, but our program doesn't use it. Siemens, you can pick either one. You can either use the block timer, which I like because it sets up, it's a lot easier to understand, or we can use the coil timer. The block format, this is what we're using. So this is what we're going to use. So inside this thing, we have three, not registers, guys. I thought I corrected these. We have three elements, with words. If you look this up in the actual book for the, if you look this up for the actual data book or the book that comes with the PLC, they call them elements. And each one of these are 16 bits, so each one of them is a word. So we have one called the preset. This contains the preset value that the timer is initialized to hold. Then we got one called the accumulator. This is the 16-bit register that actually holds the current time while it's timing. So if we look at this, we'd actually see it moving while the program's running. And then we have the status word, which holds what we call flag bits that gives us indications when things go wrong and things go right. And it also tells us when the timer is timing. So one of our flags is timer timing. And the other one is timer, we're going to use timer done. So this is a flag. So basically a flag in computers is a single bit, part of a register. And then that flag is either going to be a 0 if what it's checking for is true, false, excuse me. And it'll be a 1 if it's checking it if it's false. So this timer timing flag, it's going to be inside this word. It's going to be a bit inside that word. So we would have to address it as a bit, right? And while the timer's timing, this right here would be a 1. And when the timer stops timing, it would go to what? A 0. The timer done, while the timer's timing, this would be a 0. And when it finally meets its final time, this would go to a 1. So if I can monitor that bit, then of course we can use that bit. If I can address that bit, excuse me, and we can, then we can use that bit to control other contacts. Everybody okay? Then there's some more in there. There's timer enabled, but that's basically telling us when the run is true. Allen Bradley's the data file 4 is used, reserved for timer instructions. Timers have addresses between T40 and T4255, so that's a lot of memory because each one of them requires 3 words. So in theory, we could have 256 timers inside the T4. Now, Ars Logic, if you're on MicroLogic 1000, that's what you got. If you're on the 1100, if you need more, you can add another data file, but it has to be above 9. And of course, it says in practice, the number of timers is limited by the amount of memory you have in your computer. So even though you can address 256 timers, you might not have enough memory inside your PLC to handle it. We have what we call a time base. This is what gets people messed up. Basically, to figure out the time, we're going to have a preset register. So let's say I put 100 in the preset register. Supposedly it says, okay, that's going to time for 100 something. Then what we do is we have what we call a time base that I could come in and I could select, let's say I put 0.01. Then the actual time would be 10 seconds. So to figure out the time on this PLC, we take what's in the preset register times the time base, and that would give us the actual time. It's not the I'm calling them registers. They're not registers. The preset word. So these are our bits inside the status register. And they're in there. I don't know if I put this in here or not, but these are bits. But we don't need to know that, what bit number they're in the status register. What they've done is they gave these things names. So it's kind of like we use symbols. Once we assign an address to a symbol, we can use the symbol instead of the address. So I don't need to know that the enable bit is bit 15 inside of the status register. What we do is we give it a name. Okay. So first of all, we'd start off with T4, and this would identify timers. And then we're going to put a colon. Then this is where we're going to put the number, the actual number of the timer. So this could be a number between 0 and 255. You don't even have to go in sequence, guys. So I would come up here and I'd put 0. So this is going to address timer 0 inside the T4 file. We're actually addressing 3 words. Then I could come up here and I could put slash, and I can identify the enable bit. Well, what they've done is they've given the bit a name. So I could say T40 EN, and then that would be the way I would address the enable bit. So I don't need to know where the bit is inside the status register, because RS Logic 500 is giving that bit a name. So if I wanted to see the timer was timing, so this slash says this is a what? It says this is a bit, right? So the timer timing would be, I could say T4:0/TT. Or if I needed the timer done, I could say T40/DN. And you're addressing a bit in the status register, but what's really nice is they've given it a name. And we can look up the data book and it would show us the bit, and I could substitute the bit, but there's really no need to do that. If I want to address the accumulator, it's a word. So I'd say T4, then I'd specify, then I would put dot AC, I think it's ACC. No, I didn't give you the abbreviation. It might be ACCM, I don't remember. We'll have to look at that. If I wanted to address the preset register, then I could say T4:0. Since the preset register is a word, then we could put PRE. So they're given names. We have 2 types of timers. We have what we call non-retentive timers. A non-retentive timer will reset the time when the rung becomes false. A retentive timer will hold the rung. So it will hold the accumulator unless you clear it. So non-retentive timers, what do? If you make the rung go false, it'll automatically reset the time. Retentive timers, if you make the rung go false, they will hold their time unless you clear out the accumulator. So this is us. So we use block. So what we'll do is, first of all, when we set up a timer, we'll pull down a timer and it'll put this guy right here in there. This guy will be blank. So first of all, is we're going to have to give the time, we're going to have to address the timer. So here we're addressing T4:0. So this would be timer 0, but this could go all the way up to 255. So if I added a number timer, I might call it 24:1. This is the time base. The time base is the multiplier. You do not enter that. It's not a register. You actually select from what is available. This is the preset. So what would my time be? So I got a preset of 500. This is an on delay timer, by the way. See, T on. So this is an on delay timer. I have a preset of 500. I have a time base of 0.01. So what would my time be? 5 seconds. 5 seconds, right? 5 seconds. But I could come up here and put 5, and then I could use a preset of point this, and then it would be 500 milliseconds. So this is the way we could get down below a millisecond. So normally if I'm going to use seconds, I would use a multiplier of 1. Normally, right? You understand? A time base of 1. If I was going to try to get milliseconds, then I would use another multiplier. Are we okay? That makes sense. So let's go back in, let's pop up RSLog at 500. Hopefully I still have it. I don't think I got it up. I should have left it running, guys. It is. And I'm gonna come up here and start a new program. And no, I don't want to. I don't want that. I'm gonna come up here and start a new program. Bring down rung, and we'll just put a switch. We'll make it very simple. Put in a new rung, start a switch. We'll find this the input total 0/0. We'll call this start time. And then here's our timer instructions right here. So I'm going to click on, in my palette, I'm going to click on this. We have T on, T off, RTO. This is non-retentive, and this is reset. We're going to have to look at it in a minute. So I'm going to pull down a timer. Oops. It's an output instruction, so it automatically moves to the right. Then I'm going to come over, starts off with a question mark. So we're going to have to start off with T4. Now, why we have to do that? Because some of your PLCs gives you the ability to add more timers. Okay. Then I'm going to say what? Colon. Now let's assign this to timer 0. It's going to give it a symbol. And then we can call it anything we want to. Timer 1. Okay, so there's my timer. Now what we need to do is we need to go to a time base. So notice what I'm going to do is a little scroll button. So these time bases are built into this PLC. So I've got a time base of 1, which is the default. I could use a multiplier of 0.01 on this PLC, or I could use a multiplier of 0.001. Now to me, it don't make sense to come down here and use this, and then up here enter 500. What I would do is I would come over here and make this 1, and down here I would enter 5. So about the only time you need to use those other time bases is if you want to go below 1 second. But if you're going to be in seconds, you might as well just do what? Use time on you. Preset for 5, so this guy's going to time for 5 seconds, and we'll come up here and check it for errors, and there's absolutely no errors. The accumulator, this is what's going to show up. So preset is what we're going to time to. Accumulator is going to show me the accumulated time. I'm gonna have to get rid of some of these. Well, it's no big deal. These are served on our 8 terabyte file server that our program is over there, so I got plenty of room. I don't even think, with all the stuff we got going on, I don't even think we're using a terabyte yet. Go online. Okay. So I'm gonna come up here and I'm gonna hit switch 0. And can you see the accumulator? So it's gonna start accumulating. And then when it gets up to 5, so notice as soon as the rung went true, the enable went true. But when did the done go true? After 5 seconds. Now notice, if I come over here, this is a non-retenue timer. I'm gonna start it, and then I'm gonna make the run go false. What did you see? The accumulator automatically reset to what? 0. So this is a non-retenue timer. Okay, so far. Okay. So what I can do now, let's go offline. And what I'm gonna do is I'm gonna add another rung. Come on. Come on. So I'm gonna come down here, I'm gonna add another rung here. So this is what I don't like. Now I gotta go back over here, I gotta hit user. Now what I'm gonna do is I'm gonna put a contact down here. And I'm gonna assign this contact to timer 4, :0, / done. And what's nice about this is that I don't need to know what bit that is in the status register. All I need to know is that it's given a name. It's called the done bit. So when this right here goes true, this will go true. So we'll turn on our motor after 5 seconds. I think it's still hooked up to output of 0:0. We'll call this motor 1. We'll just call it M1. So we're going to download this. Now it's asking me for a revision. It'll save a backup. It'll just call it backup. You have an option of actually giving it a revision number so you can keep up with your revision. Okay, so we're back in. We're going online, and I'm going to come up here, and I'm using the done bit. So I'm going to come over here and flip out 1. And then after 5 seconds, the done goes through and my motor runs. And if I turn it off, it automatically resets.
Did you make a done bit?
Well, the done bit is there. So I didn't make the done bit. I used it to address a contact. I guess that's what you're saying. Yeah. So I could use timer timing. So I could come down here and put a rung and make something rung while the timer's timing. I could use, we don't normally use enable because when the rung's true, we can enable them. We could put more control in here. I could put something down below this, so I could come up here if I needed to, and you won't hear the motor, but let's go back and so I need to go offline. And like I said, I don't know how it got over here, not over there, but that's okay. So we'll come up here and we'll come up here and we'll put in another rung. It's not pop this down, put it down. And then over here, we'll use another coil. So enable, we usually don't use that. One of the things they don't show is they don't show the timer timing. The timer timing is available to us. T4:0 / which means I'm looking at a bit, right? You understand that? Timer timing. And we could change this to a normally closed contact. But here, those symbols that we looked at, that applies to relay logic. By the way, we could have a timer start another timer. So we could do sequences with these things, which is pretty interesting. So I could have the timer done, start another timer. Instead of sacrificing one of my inputs, we'll use the V3 file here. Oh, my watch is on dead. Let me go past time. So switch this on. C3 goes true. Timer's timing after 5 seconds. Timer stops timing, just so here goes off. So timer timing is true while the timer's timing. Timer done is true when the timer is what? Done. Everybody okay? Let's come up here and change this to an off delay time. That's not gonna let me. I think it's POF. Nope. Dang it. No, it's don't let me. It's not gonna. POF is right. It's not gonna let me change it. Let's change. Let's go here and we'll. Oh, I know. Why can't I change it? No, right here. Yeah, I'm in remote run. I got to go offline. So that's one of the mistakes y'all make too. Y'all do the same thing. Okay. And that's what's so neat. Well, I can make this if I know the little mnemonic, I can change this to a normally open context if I want to, which works out really well. So this is going to be different. So here we got the same time base. We're going to time for 5 seconds. But what we're going to see now is, well, let's download it. So RSlogic 500 uses block time. So what you need to make sure you understand is these different things, the preset. So what is the preset? So you're going to have to enter something into the preset. So the preset is where you want the timer to time to. But that's not exactly right. It times the time base, right? You understand that? Which is kind of strange. Most PLCs after this, even Logic 5000 don't use this. But unfortunately right now you're not teaching 5000. The Siemens, so in RS Logic 5000, everything's in milliseconds. So if you wanted 5 seconds, you would have to enter 5,000 if you wanted 5 seconds. On the Siemens portal, if you want milliseconds, you say 500, you put MS for milliseconds, well, which is pretty neat. So I really like that. So here we changed to an off delay timer. We downloaded it, right? So here I'm going to flip my switch. Timer timing is doing the same thing. This guy here came in instantly. And after 5 seconds, it's turned off. So timer timing works exactly the same way, whether it's an off delay or an on delay. It's that done bit that changes. So the done bit, so what did happen? So right now the done bit is going to go true right off the bat. And then what? Then it times after it goes off, right? So this is going to stay true, 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 until this right here goes off. And the timer starts timing. Everybody see that? So that's an off delay. What about an RTO? So let me go offline.
One more time, the timer bit, is that what's turning the motor on, going off, going straight off? Or could you turn the motor on and not have that timer bit?
This guy right here?
Yeah, that right there. You have to have that motor turn on.
Oh, I could put a push button in parallel with it, so I don't know what, there's all kind of stuff that could turn the motor on. So we have the option, if I go offline, and it's a good question. But I could come up here, I could come over here and I could put a down drop right there. So like, tell it where I want to put that. And then I could pull this in here. And then I could come over here and then I could change this to input colon 0, 0/1. This is bypass. So what I did is I just set up an OR, right? So now I can turn on the motor two different ways. This is what's turning on the motor right here. It's this output. So I have the motor connected to this output. This is a contact that's controlling the run.
Okay, so the timer done is
Well, it's a contact. Here it's not an input. You're right. We call it an input instruction because it goes on the left, but it's not an input on the push button. So it's an input instruction, but since it's not so this examine if open and examine if closed only really comes into play. We need to really consider that when we're on actually an input switch or an input push button. After that, we can just treat it like a normally open contact. So this says, okay, when this guy right here goes true, this contact is being controlled by that, and it'll go true. So, but like we said, this might not be, and this is not what's turning the motor on. It's the output going true that turns the motor on. And so I've got an OR set up now, right? So right now I can turn on the motor two different ways. So you can't say, is it the only thing in that circuit a while ago? It was. That make sense?
Yeah.
Okay. But notice here, the contact change states instantly when we hit it. And the timing occurs when? For an off delay. So the time delay, so if I come over here and I energize my timer, I'm going to use the switch. Okay. As soon as I do that, the motor comes on. All right. Well, it's an off delay timer. Right now the rung is true. So the rung's true. It's an off delay timer. So I've got the door on my car. I've got the door on my car open. So how long would the dome light set on your car if you leave the door open? Okay. When does the timer start? When you close. So what this is saying is that the timer done tells us when the timer finishes timing, but this is an off delay. So this went true instantly because the timer is not on energized, it's on de-energized, right? Okay. Flip it off. Motor keeps running, but now the timer's timing because I made the run go false. So an on delay timer times when the run goes true. Off delay times when the run goes what? False. Are we okay? Oh my, watch what did. Not to me. And you're right. In relay logic, we have the same problem because we have off delay timers and on delay timers. The only thing I can is related to off delay timers. You have several of these on your car. Yeah. So as soon as you open the door, the light comes on. Then when you close the door, which means off, that switch on it off, and then it times after that. If it was an on delay timer, I would open the door and the light wouldn't come on until after 5 seconds, and then the light would come on. So I don't know what on the car would have an on delay timer. So we're going to change this to a retentive timer. Oh, I'm still on one. Yeah, I thought I went off one. So y'all got me talking. So if you're trying to change an instruction and it don't change, then odds are you're still what? Still online, right? Okay, so we change it to an RTO. And then we'll download it. We're going to have to modify this program a little bit. So there's no syntax errors, but there's a problem in the program, but it's in the right what? Syntax. Okay, so this is an on delay timer. We do not have a retentive off delay timer. It's only a retentive on delay timer. Set up for 5 seconds. Let's get this. Sometimes they let you change things. Let's see if they let you change it. Oh yeah. So some things let you change it while you're online, by the way, and that's one thing they let you change. So I'm gonna come up here and I'm online and I'm gonna flip the switch. It starts timing. I'm gonna turn the switch off. What happened? It didn't reset. Yeah, so your off delay and your on delay, they reset automatically when the run goes off. Okay, come up here, keep it. Now the motor turns off. Now turn it off. This thing is done. It's going to stay done from now to doomsday. How am I going to turn that dang motor off? I could force it, right? Any ideas? There's got to be more to it. So I've got to have some way to reset that thing back to 0. So let's go offline. So this instruction is required for this. And I'll put it right below it so we can see it. And you can have anything reset this timer, but what we're going to have to do is we're going to have to reset the timer. I don't know what I just did here. Okay. So I'm going to come up here, right here, I'm going to add a rung, but this rung could be anywhere. I'm going to add a rung. I'm going to put another button on there. But this could be done by anything. So I could, okay. So right now I'm going to use one of my inputs. So we'll use, we're not using input 0/1. And that's what, yeah, we are using that. That's like 2. Don't let me change it. And I'm not going to give it a zero. Well, I will. So you notice in the timer group, we've got, can y'all see this? I know it's a little bitty. It's called RES. This is where we reset. And then I'm going to give it the same address, C4:0. Okay, we don't have any errors. We'll download it. And then after this, we'll go home. So what we'll do Monday is we'll start off the class, we'll go through timers, and then we'll come counters, and we'll be in lab. And then we'll be in lab all day Wednesday, and we'll be in lab after the test on Monday. And like I said, I'll see what labs we're going to have to make sure we do, and then what labs we don't need to do. And we'll have to trim the labs. So we're here. So same thing now. So now notice, even though I was offline, it kept the time. So I'm gonna hit switch 2. And notice what the accumulator did. Go back to 0. Now, the only retentive timer we have is an on delay timer. We don't have a retentive off delay timer. So the on delay timer, that's a non-retentive. The off delay timer is a non-retentive. This is an on delay retentive timer. So notice I make it go false, but I can do this. This is what's nice. So I could come over here. I'm sorry. I could start the timing. This would go false, right? Then I could come up here. I could start the timing, then make this go false, and it holds the what? Holds the time. So RS Logic 500 uses block timers, which I like on timers. I pulled it off because we couldn't turn it off all day, but I could do that too. So thank you. So on delay timer. Okay, so it's on delay. So now we've energized the timer, nothing's happened. Then it's going to revert as soon as it gets to 10 seconds. The motor came on. Now I cause this to go false. Motor's going to stay running because this is a retentive timer, right? So I do what? We'll show y'all, we got one more thing we need to do, in class with timers, and we call them cross-coupled timers or cascade timers. What we, in industry, you'll see lights flashing all the time. And they stay on, off, on, off, on, off, on, off. So we'll show you how to do that. There's an easier way to do it. Most PLCs give you an easier way to do it, but basically they have two timers that are cross-coupled. And we'll show you all that, and then we'll look at counters, and then we'll be through for lectures for this semester. So any questions? Timers, really neat. So y'all just ready to go, right? So y'all thinking, don't ask him any questions. I know.